French company. Alain Fèvre from the CEA was supposed to present this, but we couldn't make it, so I'm presenting it for him. I will present a joint work we have done between PragmaDev, my company, and the CEA, the research center in France. So I will present what we do first, what the CEA does, and what we have done together in this. This is not working. Is it connected? I use this keyboard somewhere. So PragmaDev is an SME, a French SME, and we do modeling and testing tools since 2001. And we have customers, professional customers. We also work with the universities, since we have, as you can see, 700 university licenses used around the world. It's free to use, so if you want to use the tool, do not hesitate to contact us. And we have always tried to work with research labs to investigate new features like model checking. We have done with Alcatel, for example. Last year we have presented something on the properties, the verification of properties on the message sequence charts, for example, with Thales. And that's what I'm going to do today, is the PragmaList work. So first, what we do is that we do a modeling tool, and our focus is on executable models. And from the start, we have selected STL, specification and description language, as modeling language because it is executable. And since with that lab, what we are trying to do is to generate test cases, we definitely need an executable model to be able to translate it to some test cases. It's for us a key feature for model-based testing capabilities. So as you probably know, STL has some semantic and action language really needs graphical representation so that you can fully execute it. I insist on the fact that if you write a model, even if it's with SDL, you have to verify it's correct. If you want to generate test cases out of the model, you need to be sure the model is right. So for that, you can use a Symbolic, for example. That's what we have in our tool, for example, but all the tools have the same kind of feature. And make sure that the behavior is correct before you generate the test cases out of it. Please do that. It sounds obvious, but when you give that type of technology to a user, it's not what they do on that one. They tend to generate the test cases before verifying the model is correct. Now we have a modeling language. We have selected STL, and we needed a testing language to put in front of it. And we have selected its natural counterpart, TTCN3 testing language, which has basically the same level of abstraction as SDL, the same type of execution, so it fits perfectly to execute TTCN3 test cases against SDL models. So what we have in the end is, if you look at the V cycle roughly, you will have on the left the SDL part with the model that can be more or less refined, and on the right part the TTCN3 test cases that can be more or less refined as well. You could even generate code, actually executable code out of the model or out of the test cases. So that's basically what we had, and we thought, well, if we could do some more analysis on the model and generate test cases, for example, that would be interesting. So we worked with different labs, with Verimag, with the LAS, with the CEA. And we basically found out there are two main techniques. The first one is to do exhaustive simulation. So that basically tries all possible inputs in the system. And then on the side you have properties, and each time you run a step of execution in the exhaustive simulation, you verify the property. Or you can run symbolic resolution. So that was quite new to us, and that is what the CEA is doing, and I will further develop that. And we have found that it was much more effective depending on the type of system modeling. Now, to generate test cases, you need a target. So it could be a simple target like model coverage. I just want full coverage, full stop. Or maybe some specific properties. So that's also something on the side which is independent from the technique used in exhaustive simulation or symbolic resolution. So from our point of view, we had the model, the test. We could actually already generate from execution traces directly the test. Now we're trying to do that automatically based on coverage or test objectives with the SERA collaboration. Now a few words about the SERA. I don't know if you're familiar with them. It's a very large research center in France, the Nuclear National Research Center. It's, as you can see, 16,000 people with quite a substantial budget. And they have this type of organization with fundamental research and three, let's say, axes. One is for defense, it's nuclear, okay, so it's nuclear weapons, of course. These are nuclear plants, and then you have the technological research. So that's why the research team we have been working with is. Within that research organization, you have three main labs, the LETI, the LIST, and the LITEN with their different specialization. So the people we have been working with are the one from the LIST, based in the south of Paris, so that's 700 people. Well, we didn't work with 700 people, we should work with a few of them, but the whole lab is quite big. And in that digital system part, you have, again, more specialization, and we are working with the people in the embedded systems part. Okay, so what they have done, they wrote a tool called the Diversity. XLIA is actually the language that is used as an input in the diversity tool. So it's not XML. It has an X, but it's not XML. So what it does is you input a model, and the model can be quite generic. So you can specialize it. You can say, for example, the execution semantic is synchronous or asynchronous, based on set machine or data flow. You could say that the communication is on rendezvous or FIFO. So you can precise the type of model you're putting in. Then you have some constraints or criteria to lead the resolution. You put that into the tool, and in the end what you get is, on one side, coverage information for analysis, or test cases. And that's, of course, what we are looking at now. So what it does, it's using symbolic simulations. So it tries to look at the transitions. When I say transitions, I don't really mean finite state machine transitions, because decisions within the model are also considered transitions. So it's a bit more detailed than the state-even transition, okay? So you can have a succession of transitions, and actually what you do is that you keep all these transitions and you look at it as a big equation, big mathematical equation, and you try to solve it. Is it possible? Okay? And if it's possible, in the end, you will give values to the different variables in your equation, basically. So that's what they call equivalence classes. That's a symbolic follow-up of transitions. And then in the end, it will generate a real test case with real numerical values. It will, in the end, explore the model, so it can find things like inconsistencies or deadlocks. So inconsistencies among data types. I mean, if you have simulated the model before, I mean, you shouldn't find this, okay? But deadlocks, that's interesting, okay, you can find this. Also dead parts of the model, parts that cannot be reached at all. And we have on a use case with Alstom, we found a case where some transitions could not be reached. But moreover, the result is a set of test cases. So what we have done together is that we wanted to integrate both tools. So the modeling tool and their Symbolic resolution tool. So the first step was to define how can we translate the SDL model to their language, XLIA. Okay. So we wrote the translation rules. We wrote the translator then. And we also adapted the diversity kernel semantic to fit the SDL semantics so that the execution is conformed to what you expect from an SDL model. And then in the end, we wanted as an output some TTCN3 test case generation. And that's not what they were doing by default. They were doing some informal scenarios, but we wanted some really formal TTCN3, all the data types and everything properly organized so that we can execute them later on. So that's the architecture. We wanted to keep the tools separated, so you don't. And actually, the integrations we have done with Verimag or with Fiat, we have done it the same way. And we keep the tool here, with the model and the properties. We translate that to the pivot language. So in that case, it's XLIA, could be if, or it could be Fiat. That's the, let's say, research tool. And then as a result, we re-import the test cases the tool has generated. Okay. The interest is that you can add this to evolve and then you have better versions and keep the same tool here or the other way around. In our integrations, we have focused on 4 types of targets. So the first one, the simplest one, is cut coverage. We just ask for the minimum number of test cases that will cover all transitions in the model. For a user, it's very simple. You design the model, you press a button, and that's it. Okay. So for industrial user, it's perfectly fine. Okay. But you can also do some more complicated things. For example, you can target transition. Sometimes you really want one test case that will execute a specific transition in the model, so you can ask for that. Another one that you have a property, static property, like I don't want to reach, or I want to reach a process state or a variable value, for example. Or it can be a more complex property, and in that case we use observers. It's like a state machine, where you can have a succession of temporal rules to specify a property, a target. I'll make a PowerPoint demonstration, which is not as exciting as a real demo, but still it gives you an idea of what it can do. We have, as a first use case, designed an access control system. So that's a system in which you enter your card and you type in a code. So the card has an input parameter of 65,000 each different value possible. And the digits are, you can type in 3 digits. And actually the number of digits is 11 because you have included the star and the hash key in that. Okay. So that's 12 possible keys. So we make sure the model is correct, and the tool did some simulation and so on. And we ran the basic one. The basic property is that we just want coverage. Okay. You can define maximum depth or width, but you don't have to. You can just click cut coverage and let it go. And we made this live graph, so when you do the execution, you have this sort of spider graph that animates and shows you where you are. But in that graph, the main objective is coverage, okay? So basically the vertical axis is what you're looking at. The others are more informative to see where you are in the symbolic resolution. And in the end, it will generate a set of test cases. So for that example, we generated like 8 test cases, and if you run them against the model, you verify it has actually covered all the transitions. this is done within 10 seconds, to give you an idea. So it's very quick, okay? And we actually made a comparison between this symbolic kernel and some exhaustive simulation technologies, okay? And we found out that if we use, for example, VeriMag toolbox, which does exhaustive simulation, we have to restrict the digit range or the card range to 2 values instead of 65,000 and 12, okay? To have an equivalent execution time of 13 seconds, okay? But if you put the full range, I mean, we cannot even do that on that simple system with VeriMag. So we thought it was very interesting because actually the symbolic kernel was actually going faster than exhaustive simulation with 1 value basically, or 2 values. So we thought that was very interesting. I'm not saying this is going to work for everything, but it's quite efficient. So we have been, a few use cases. I said a few words about some, but there are others going on, but all this is quite new. So if you have a use case in mind and if you want to try it out, it might be interesting to have, let's say, a domain-specific model with some domain maybe constraints or things you want to investigate. So we would be very interested if anyone has a use case in mind. So as a conclusion, what we are trying to do here is to provide a model-based testing solution that is completely integrated because from a user point of view, you design your model, you configure your symbolic resolution kernel, and it automatically generates the XLIF files, and what comes back is a set of TTCL3 test cases. So from a user point of view, you don't see, let's say, the underlying complexity of this tool. Okay. The other good thing is that the model is not a model for testing. It's an SDR model, so it could be used for specification, design, or maybe code generation or anything. And you could use that as a model for test case generation. I think it's important because very often model-based testing tools tend to reinvent a new language which is dedicated to testing. And we saw so far that the symbolic kernel was quite efficient in its resolution time. That's another thing I didn't say actually, is that it's efficient in time, but also it reduces the number of test cases. I said it generates the minimum number of test cases, so it really reduces the number of test cases after resolution. And when I talk about 10 seconds, it includes the simplification of the number of test cases. Well, I'm basically done with this.
Questions?
Daniel always has a question.
Yes, of course. Are you saying that you don't need to restrict the range of the data variables that you have for this to work?
You're talking about the values?
Yes.
The value of the variables? No, we don't.
Never. So far.
That's it.
Okay. That's cool.
It's true that when we did the integration with VeriMag, we had to restrict values, and actually spent quite a lot of time trying to restrict the values. Because sometimes it's not easy to do with the data types. You sometimes have to write an observer to restrict the number of cases and all that. So you have to fight with that, and it's exhausting. So in that case, yeah, so far, there's no restriction. We have restrictions on some types, some data types, okay? But not the values, not the range of values.
Any more questions? Okay, then we conclude the session and we can proceed to the coffee break. And
Yeah.
thank you very much.
Yeah.